Okay, this video is going to focus on correlation, and on correlation, it just talks about the strength of a linear relationship. Our previous video, the residual plot, talked about whether or not a linear equation was the appropriate or most appropriate, but it does not tell us how strong that linear relationship is. So we have something we calculate called R, which is the correlation coefficient. No, we only talk about the correlation coefficient when we're talking about linear relationships, and the calculator will do this for us automatically. So it's really nice that we have, but you always have to make sure your stat diagnostics are turned on. And real quickly, I'm going to just remind you how to do that in case you forgot or missed one of the previous videos. So if you go to mode and scroll way down to stat diagnostics, make sure it's turned on, otherwise you won't get that information. All right. So the correlation coefficient measures how closely the points in a scatter plot are spread out in the regression line. So how far are the data points are from the line. The value, and it'll always fall in this range, -1 to 1. All right. So -1 to 1. If you have something greater than that, it's wrong. So, and by the way, P is the Greek letter rho. It's actually rho for our correlation, but we only need to worry about R. So -1 is less than or equal to R is less than or equal to 1. If we have R equal to 1, we have a perfect positive linear correlation because R1 is positive. What that means is every single data point lies directly on the line and we have an upward slope. If we have R equals -1, we have a perfect negative linear correlation, which means every dot lies on the line, but we have a negative slope. If R is close to 0, then there's no linear correlation. All right. So just because there is no linear correlation does not mean the variables might not be correlated. It just means that a line is not appropriate. A linear equation is not appropriate. So how strong is strong? Well, these are rules of thumb. They seem to work fairly well for AP. So if the absolute value of R is greater than 0.75, there's a strong linear correlation. So 0.75 would be strong. 0.8, 0.9 would be strong. And also -0.75 and -0.8, -0.9, et cetera, would be considered strong. If it falls in the range of 0.4 to 0.75, it's moderate, all right? So moderate. And if it's less than 0.4, there's a weak. Super important thing to say, a high correlation or association does not mean causation, all right? And like we said, otherwise, just because the variables have a correlation close to 0 doesn't mean they're not highly correlated. It just means they're not linearly correlated. So take a look at these graphs. We can look at this and go, you know what? That's pretty highly correlated, but it would have a R of about 0. This would also have an R about 0, and you go, well, why? Because I would not know whether to draw a line like this or like this or like this. And because I don't know the direction of the line, it's not highly linearly correlated. All right. So these were not highly linearly correlated, but they are highly correlated. So let's real quickly talk about how to get that. Well, on page 246 of the note spiral, so page 246, and we're continuing back to the airfare problem. In the airfare problem, we had this data that we entered into the calculator. And here's how you get that information. So you're going to go to stat calc. Well, first off, I've entered the data in. I'll clear out L3, but I have my data into L1 and L2. So distance, and I'm going to go stat calc. Then I'm going to drop down to number 8, linear regression. X, this is an L1. I'm going to go ahead and store this. So alpha trace. and this R is 0.694. So the R for the data we entered was 0.694. And I noticed that it is positive, all right? And so it's positive, but it falls in this range. So there's a moderately strong positive linear correlation, all right? So our R is 0.694. And we previously checked the data out and determined that using a residual plot, we determined that a linear model was the most appropriate. Remember, the residual plot tells you whether or not the model is appropriate. The correlation tells you the strength of the model and how useful it is in prediction. As we get closer to +1 or -1, the better the prediction we can get. All right, appreciate you watching. The next video, we're going to cover a bunch of definitions. Thank you, and see you in the next one.